Good morning, guys. Today we are going to be finishing up with the last couple topics on solutions before we start transitioning to um, a little bit of sprinkling of acids and bases before we start work on our final projects for the semester. We're not going to cover the entire chemistry curriculum this year. We just haven't had time, but we're going to get through as much as we can before I give you guys your finals and your final projects. So, what we're talking about today is colligative properties. When you mix a solute and a solvent, you create a solution. We know this, we've talked about this for the last few days, talked about different concentrations and things like that. Um, in a solution, in any mixture, the two compounds do not chemically combine, so we can physically separate them. If you put salt into water, you can evaporate the water and be left with your solid salt, for instance. But when we do put a solvent and a solute together to make a solution, that does have an effect on some of the properties of the solvent. Um, the classic example of this is when we put salt on roads. So if we look at our slides, here's a little IA guide, directions for the reading, and then your notes. A colligative property is a property of a solution that depends on how much solute is in it. And this non-volatile solute, that just means that it's not causing a reaction. It's not volatile, it is not reacting with anything, it is stable. So when we add a stable solute, like salt, to a solvent, like water, colligative properties are the properties that change. Some examples of this, and there's some more notes about colligative properties though, are things like antifreeze, which your practice questions are going to be about antifreeze. When you put antifreeze on your car windshield, it prevents water from freezing on the windshield. One of the most common things that solutes affect are freezing and boiling points. So you can see here, this is the size of your coolant system. So let's say this is a coolant system in the engine of a truck, right? If the coolant system is 12 quarts and you put in 3 quarts of antifreeze, you can protect this down to 10 degrees Fahrenheit. If you put in 7 quarts of antifreeze, you can keep this system from freezing all the way down to negative 57 degrees Fahrenheit. So if you increase the concentration of a solute, then the freezing temperature of the solution will be depressed, will decrease. So this is the idea that we're getting around. The reading, the reading right here, you are going to do this reading. There are some guiding questions that, yes, you have to do. There are practice questions, or there's the notes that are in the slides. I noted what slides they're on. And then there are some practice questions. These practice questions are based on this chart right here, interpreting this chart. You have the size of the cooling system in your truck or your engine or whatever you have it. And then you have the temperature to which the engine will be protected with different amounts, different concentrations of antifreeze. So that's what you're going to be doing today, learning a little bit about colligative properties. Hopefully you can tell me why we put salt on the roads after this. And I hope you guys have a little fun and learn a little bit about how chemistry is used in the world. And maybe you'll notice where these colligative properties are flexed in and around your daily lives, like in your kitchen when you're cooking things. If you notice something like that, if you start to pick up on those, leave a comment just to see where you, just stating where you saw it and what you think you observed, and I'll give you feedback on it. We'll try to come up with more examples of where we can see colligative properties at work in our everyday lives. All right, guys, have fun.